All right, today's lesson is on the rate of change and slope. So there are many ways that we have seen slope in the past. One way you might remember it is rise over run. You probably remember that from graphs. You might remember the official slope formula, which is y2 minus y1 over x2 minus x1. That is also slope. And you might remember it as the change in y over the change in x. And some teachers will even do the change in y written with this little delta. That's a Greek letter that means change over change in x. All right, so just another way to write that. So how much the y is changing over how much the x is changing. And then finally in y equals mx plus b, the slope is the m, the letter m. So today we're going to be focusing on slope. And we're going to calculate slope in 4 different situations, from a table, from a word problem, from 2 points, and from a graph. So we'll start with from a table. So we know that slope is the change in y over the change in x. And so we want to see how is the y changing and how is the x changing. So I'm going to look at the table and say, okay, the y is changing from 13 to 17. Oh, it's adding 4. From 17 to 21, it's adding 4. 21 to 25, it's adding 4. 25 to 29, it's adding 4. So I can see that it's adding the same amount each time. We'll see if it's also doing the same thing on this side. So from 5 to 7 for the x's is adding 2, adding 2, adding 2, and adding 2. So we can see consistent growth. That means that this is linear. So we can find the slope. So how much is the y changing every time the y is changing by positive 4? Right, it's going up 4, so that's going to be on the top of our fraction. And how much is the x changing? The x is changing by positive 2. So that is the bottom, the denominator. I want to simplify this if I can. So 4 divided by 2, that equals 2. And so in this problem, I would say m equals 2, or the slope is 2. Right, so the slope from this table is 2. So that's the first way if we have a table. The second situation is from a word problem. This one says, after 30 minutes in flight, a plane had traveled 290 miles. After 90 minutes, the flight had gone 870 total miles. How many miles per minute is the plane traveling? So we have some good information here. It says after 30 minutes, the plane traveled 290 miles. All right, so you imagine that plane, it's taking off. After 30 minutes, it's gone 290. And after 90 minutes, the flight had gone 870 miles. Right, and they give us a clue here in the question. It says how many miles per minute is the plane traveling? Right, so they want to know miles per minute. This word per means division. So what they really want to know is miles divided by minutes. So if I want to know how many miles they've gone, right, if I want to know what the difference is between what it was then and what it is now, then I would need to do subtraction. So I'm going to do 870 total miles minus the 290 that we had already gone before. So 870 minus the 290, right? And then I also need to know the change in the minutes. So we were going 90, or we have gone 90 minutes, but before we had already gone 30 minutes. Right? So I'm taking those away. So this is kind of like now minus then. So now we've gone 870 miles in 90 minutes, and before we had gone 290 miles in 30 minutes. So then I'm going to go ahead and use my calculator, and I'm going to say, okay, I have 870 minus 290, it gives me 580, and I have 90 minus 30 gives me 60. I know that this can simplify because they both end in 0, so I can divide by 10. So I have 58 over 6, I know that it can divide by 2 on top and bottom. So this would be 58 divided by 2 would be 29 over 6 divided by 2 would be 3. And then I can check, does 29 divided by 3? No, it doesn't, not evenly. So I'd say they're going 29 miles per 3 minutes. If I do 29 divided by 3, I get 9.66666 forever and ever miles per minute. Right? Both of these are reasonable answers. Right? This would be like this would be the exact version, and this would be the approximate version. Right? We'll talk a little bit more about that, but for now you can use either of those answers. All right. From 2 points, we need to go ahead and use our slope formula, which is y2 minus y1 over x2 minus x1. I'm going to go ahead and write that here. y2 minus y1 over x2 minus x1. Remember that coordinate points are always x comma y. So I have x and y. And since there's 2 points, I'm just sort of separating them. So I'd say, okay, this is point 1 and this is point 2. So this is y2 or x2 and y2. So then I'm just going to go ahead and plug them in the right place. So I have y2, so I want to find y2, that's 5, minus y1, so y1, that is 3. I have x2 is 2, minus x1, and x1 you see is negative 4, so negative 4 like this. Some people will write parentheses here, right? As long as we remember that a negative and a negative will make this into a big positive, like that. Subtracting a negative is like adding. So I'm going to write it with parentheses here. I'm going to say, okay, 5 minus 3 would be 2, and 2 plus negative 4 is like, 2 minus negative 4 is like 2 plus 4, which is 6. I'm going to go ahead and simplify by dividing by 2 on top and bottom. That gives me 1/3. Right, so 1/3 would be my slope. I could say m equals 1/3, or I could say slope is 1/3. So this is from 2 points. And then finally we have from a graph, right? Remember our slope is rise over run. So I want to choose 2 points. I don't want to choose this point because it's like kind of in the middle. I want to choose what's on a lattice point, so I want to choose something like this or like that, where the 2 points are coming, the 2 lines are grid lines are coming together. So in this case, I can see that there's a point right here, and there is a point right here, right? I don't see any other points, so I'm going to use these ones. So always moving from left to right, right? I want to see how far down or up I have to go. In this case, down. I'm going down, and I'm running to the right. So I had to go down 1, 2, 3, 4. So this is down 4, negative 4. And I'm going 1, 2, 3, 4, 5 to the right. So my run is 5. I know that it's down because if I think about this little guy and he's always on the left side, he would have to go down the mountain in order to get to the other side. So I know that this is a negative slope. That makes sense. Negative 4/5 because it cannot be simplified. So that is how to calculate your slope from a graph. So 4 different ways to find slope. They are all related to each other. Make sure you ask any questions that you have. Thanks, guys.